welcome back to Organic Chemistry Decoded, guys. We got some more practice problems for you. I hope you guys are having a good week after the 4th of July weekend. I know it kind of sucks having a long weekend and then going to work, school, but here we are still grinding. So we have another predict the product practice problem today, and we're going to work through it together and we're going to do the mechanism. Now, if you want, this is a great time to pause the video, screenshot it, work this through on your own, come back to see if you get it. Or if not, that's fine. We'll work through it together right now. And before we get started on this, remember to send this video to a friend that you're in organic chemistry with and like the video and to hit subscribe so you get the rest of the videos. So, beginning with this, we have this compound here, which would be, I guess, 1, 2, 3, 4. I guess it would be 2-bromobutane. And it's drawn like this for a reason because that's how we're going to react it. And then we have this right here, this NaSH, which is sodium hydrosulfide. And you can think of it similar to sodium hydroxide, but with a sulfur here instead of an oxygen, and it's in DMSO, which is a polar aprotic solvent. So, like I said, this is drawn a little different for a reason, and then that's because that's how it wants the answer. So whenever you see something that's drawn in a particularly different way, that's probably how the answer is going to be. It's a clue. Also, as you can see here, we have our wedge and our dash drawn explicitly, which is another hint. So generally, as a rule of thumb, whenever you see stereochemistry in the starting material, it's going to want stereochemistry in the product. That's not always true, but it usually is. So just if you see stereochemistry to start, be extra careful and pay attention to your stereochemistry. So what do we have here? We have a secondary substrate, and we have this right here, which, like I said, it's similar to sodium hydroxide. It is a base, not as good of a base, but it is much more nucleophilic. So it's a great nucleophile. So what do we have? We have a polar aprotic solvent with no heat. So what are we going to get? We are, like I said, we have good nucleophile. So we're going to do a substitution reaction. Like I said, this is aprotic though, so we're probably going to do SN2. And, that is what's going to happen actually. So first, I'm going to redraw this ever so slightly up here. We have our wedge, that would be our CH3, and then I'll draw it like this. And then what happens is our hydrosulfide comes in, and remember, SN2 is nucleophilic addition, and nucleophilic addition is always backside attack. So it's going to come in from the back there, and it's going to push off this Br. And what we're going to be left with is this product right here. Mm. And we have our thiol on there now. So now this has stereochemistry, but is it the right one? Because what we need to remember is that when there's an SN2 reaction, we get inversion of stereochemistry. So now, actually, as I'm saying this, I don't know that I've ever done a video on stereochemistry, but hopefully you guys have covered it in class, and we can do a quick walkthrough right now. So the first thing you want to do, we're going to take our starting material, and you want to number them in terms of importance. So bromine, most important here. Then you have a ethyl group, that'll be 2, a methyl group will be 3, and then a proton or hydrogen is always the worst, so it's 4. You don't always have a hydrogen, but if you do, it makes life so much easier. Then you want to imagine that you're looking through it. So this is where it's good to have a model kit, especially if you're not good at imagining this in your head and visualizing it, where you're viewing it where the least important part is in the back. So you're kind of, you know, viewing it like this. This is where Newman projections are a big help for a lot of people. So we draw it. So this is our central carbon. And do it like this. Then we have our Br here, BH3, ethyl, 1, 2, yep. And Oh, I just realized I put an extra one up there and there. And then we're going to have our hydrogen. Remember, dash means away, wedge means coming at you. So we are looking at this in the correct order. We number our substituents, and then we go with it goes clockwise to the right, which is R. It is an R absolute configuration. Now, if we come over here to test to make sure we drew this right, we have again 1, 2, 3, and 4. So we're looking, and so we would draw our Newman projection this way. So thiol. So then we label them again 1, 2, 3, and 4. Now we're going counterclockwise or to the left. That means it is S configuration. And now, like I said, because SN2 leads to stereochemical inversion, that means we have drawn the correct product. So we started with our configuration like this, and we ended up with our S configuration like this. Now there are a couple different ways you can draw it, okay? In terms of who has a wedge, who has a dash. But the most important part is that when you draw it, make sure your absolute configuration is the opposite of your starting configuration. Okay, guys, hope that was helpful for you. As always, drop something in the comments that you're struggling with in organic chemistry. And remember, there is the YouTube channel now that has all the videos that I post. If you ever want to go back and look at them and you're struggling, you can't find them on TikTok, it is on YouTube. The channel's under the same name as this channel. All right, guys, can you have a great summer?